Here is our final set of multiple angle formulas. In this case, we have the half angle formulas. And notice they are called the half angle formulas because inside of each trig function, we have a u over 2. Notice the sine of u over 2, cosine u over 2, and tangent of u over 2. Well, the sine of u over 2 is equal to plus or minus the square root of 1 minus the cosine u divided by 2. The cosine of u over 2 is equal to plus or minus the square root of 1 plus the cosine of u over 2. And the tangent of u over 2 is equal to 1 minus the cosine of u divided by the sine of u, or the sine of u divided by 1 plus the cosine of u. We have two separate formulas for the tangent of u over 2. Again, it does not matter which one you pick. You'll get the same answer both ways, so choose whichever one is your favorite. All right, one important thing to make note of, the signs. And when you read the word signs in mathematics, we're talking about positive or negative, okay, plus or minus. The signs of the sine of u over 2 and cosine of u over 2, that's in this formula here and here, okay, are going to be determined by the quadrant in which our angle u over 2 lies. Okay, so u over 2, you're going to have to figure out what quadrant that angle is in. If it's in the first quadrant, sine, you know, is positive, and cosine is going to be positive. If it's in the second quadrant, sine will be positive, cosine will be negative. If it's in the third quadrant, sine and cosine are both negative. And if it's in the fourth quadrant, then sine is going to be negative and cosine will be positive. All right, so you'll have to figure out which quadrant u over 2 is going to be in to determine the sign, the proper sign to use. All right, again, half angle formulas, they allow us to extend the scope of finding exact values when evaluating trigonometric expressions. As I mentioned before, you don't have to memorize these. They will be provided, but it is your responsibility to know how and when to use them. So let's go through a few examples here. It says, use the figure to find the exact value of the trigonometric function. All right, and we're given a right triangle. And again, don't forget, whenever you see right triangles, think of your right triangle trigonometry. So, toa. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So here we are asked to find the sine of theta over 2, or half of this angle, the sine of half of theta. That should tell us we want to use our half angle formula for sine. Our half angle formula for sine is sine of u over 2 is equal to plus or minus the square root of 1 minus the cosine u divided by 2. In this case, the only difference, instead of u's, we have thetas. So that means in order to use this equation, we have to know what the cosine of the angle theta is. Well, if I have a right triangle to evaluate cosine, I need to know the adjacent side and the hypotenuse. That means we're going to have to use the Pythagorean theorem to find our hypotenuse. R is equal to the square root of 15 squared plus 8 squared. Plugging into our calculators, we get r is equal to 17. That is the hypotenuse of our right triangle. Okay, next, we need to determine whether or not we want the positive or negative solution. Well, if we're dealing with a right triangle, that means that all of our angles are going to be acute angles between 0 and 90 degrees, right? Theta is definitely an acute angle, which means that theta divided by 2 will also be an acute angle. And if you were to draw out an acute angle in standard form, that would mean that the vertex of the angle would be at the origin. The angle would end up being in quadrant 1. All right. And in quadrant 1, sine, cosine, tangent, all of them are going to be positive. So we know we want the positive value here. All right, so the sine of theta over 2 is equal to positive square root 1 minus the cosine of theta, that's 15 over 17, divided by 2. Square root of 1 minus 15 over 17 divided by 2. Now we can begin to simplify. In our numerator, we get a common denominator. This would be 17 over 17 minus 15 over 17. That's 2 over 17 divided by 2. Know that dividing by 2 is the same as multiplying by 1/2. That gives us the square root of 1 over 17. To take the square root of a fraction, we take the square root of the top and the bottom. The square root of 1 is 1, leaving us with 1 over root 17, which we can then rationalize by multiplying by root 17 over root 17, giving us our final answer, root 17 divided by 17. Let's now find the cotangent of theta over 2. Well, we're trying to find the cotangent of half of this angle theta. Well, maybe we want to use our half angle formulas. That being said, there is no half angle formula for cotangent, but we can find the tangent of theta over 2 and then take the reciprocal to give us our answer. Notice that tangent is the reciprocal trig function of cotangent. So if we know what the tangent of theta over 2 is, we can flip it to get the cotangent of theta over 2. Well, what's our half angle formula for tangent? The tangent of u divided by 2 is equal to 1 minus cosine u divided by sine u. And again, there's two formulas. You could pick either one. This is the one that I decided to choose. I encourage you to try the other one to make sure you get the same answer, but you should. All right, and we end up with 1 minus the cosine of theta. Cosine is going to be adjacent over hypotenuse, 15 over 17, divided by the sine of our angle theta. Well, the sine is opposite, 8 over 17, opposite over hypotenuse. Tangent of theta over 2, 1 minus 15 over 17 divided by 18 over 17. 1 minus 15 over 17, that gives me 2 divided by 17. And dividing by 8 over 17 is the same as multiplying by 17 over 8. Multiply by the reciprocal. Notice 17s are going to divide out. 2 over 8 reduces into 1/4. And that is the tangent of theta over 2. Well, if that's the tangent of theta over 2, the cotangent of theta over 2 will be the reciprocal of this quantity, meaning that the cotangent of theta over 2 is equal to 4. Let's look at a couple more examples. Use the half angle formula to find the exact value of the following. So we are trying to figure out what the sine of pi over 12 is. Well, pi over 12. This is not one of our special angles on the unit circle. However, it is half of one of our special angles. And in particular, it is half of pi over 6. And if you're trying to figure that out, the easiest way to do it is to take pi over 12, or whatever your angle is, and multiply it by 2. Notice that gives us 2 pi over 12, which is pi over 6. So pi over 12 is 1/2 of pi over 6, or pi over 6 divided by 2. All right, these are equivalent. The sine of pi over 12 is equal to the sine of pi over 6 divided by 2. And now that we have rewritten this in terms of an angle that we have on our unit circle, we can use our half angle formula for sine. Notice that when we plug in here, our u is just going to be replaced with a pi over 6. So the sine of pi over 6 over 2 is equal to plus or minus the square root of 1 minus the cosine of pi over 6 divided by 2. Now the question is, do we want the positive or the negative solution? All right, should our answer be positive or negative? Well, if we're looking at this angle pi over 12, that is 1/12 of pi. This angle must be in the first quadrant, all right? It's in the first quadrant, and if it's in the first quadrant, then sine is going to be positive. All right, sine of pi over 12 must be positive because the angle is in the first quadrant. So we get positive square root 1 minus the cosine of pi over 6 divided by 2. And the good news is we know what the cosine of pi over 6 is. The cosine of pi over 6 is root 3 over 2. Now we can begin to simplify. Well, by the distributive property of division, I can take each of these quantities and divide by 2. That gives me the square root of 1/2 minus root 3 over 4. If I'm to get a common denominator here to combine these two fractions, that gives me 2 over 4 minus root 3 over 4, or 2 minus root 3 all divided by 4. And now I can take the square root of the numerator and the square root of the denominator. Well, nothing is going to simplify in the numerator. However, what is nice, the square root of the denominator turns into 2, giving us our final answer, the square root of 2 minus root 3, all underneath that radical, divided by 2. Let's try another one. The cosine of 7 pi over 12. Now we're told to use our half angle formula. So 7 pi over 12 is not one of our special angles on the unit circle. However, it is half of one of our angles on the unit circle. How do we figure that out? Well, let's take 7 pi over 12 and let's multiply it by 2. If I multiply that by 2, I end up with 14 pi over 12, which reduces into, I can divide each one of these by 2. That gives me 7 pi over 6. All right, so 7 pi over 12 is half of 7 pi over 6. This is the same thing as the cosine of 7 pi over 6 divided by 2. Okay, and the good news is 7 pi over 6, that's one of our special angles on the unit circle. So what are we going to use? Our half angle formula for cosine. The cosine of u divided by 2 is equal to plus or minus the square root of 1 plus the cosine of u divided by 2. Now, we have to determine, should our answer be positive or should our answer be negative? Well, we're trying to evaluate the cosine of 7 pi over 12. 7/12 of pi. 7/12 of pi is slightly greater than a half of pi. Remember, on your unit circle, we've got 0 pi over 2. That's a half of pi and pi. All right, so that means 7/12 of pi has to be between pi over 2 and pi, meaning that this angle must be in quadrant 2. And because this angle is in quadrant 2, we know that cosine has to be negative. So we want the negative solution here. The cosine of 7 pi over 12 must be negative because the angle is in the second quadrant. So we take the negative value. Negative square root 1 plus the cosine of 7 pi over 6 divided by 2. And the good news is we know the cosine of 7 pi over 6. Go to the unit circle, find the cosine of 7 pi over 6. Well, it's negative root 3 over 2. So we end up with negative 1, adding a negative, that just turns into subtraction. Okay, and we can use the distributive property of division to divide each one of these quantities in the numerator by 2. That gives me 1/2 minus root 3 over 4. If I combine these to get a common denominator, that would be 2 minus root 3 over 4. Negative 2 minus root 3 over 4. Don't forget the negative, carries along. And to take the square root of a fraction, we take the square root of the numerator and the square root of the denominator, giving us our final answer, negative square root 2 minus root 3, all of that underneath our radical, divided by 2. All right, a few examples of using the half angle formulas.